Okay, so let's take a look at how to derive with the hyperbolic and inverse hyperbolic functions. So in your study guide, we're going to take a look at section B. So the first one says we want to take the derivative of the hyperbolic cosine of x minus 3. So to do that, I need to find the rule. And so the rule is over here on page 10. And it says that if I want to derive this, I'm going to take the derivative of what's inside, or u prime, and I'm going to multiply it by the hyperbolic sine of that u function. So the derivative of x minus 3 is 1, and then I would go ahead and take and change this over to the hyperbolic sine of x minus 3, and I'm done. So I can put the 1 out here to show you what I did with that. Our second one is the derivative of the inverse hyperbolic secant. So that is going to appear on this sheet, and it's going to be up here towards the top, this formula right here. So when I derive that, the formula says that I want to go ahead and take negative, or the opposite, and take the derivative of what's inside. And I'll put that in parentheses, that's 12x plus 3. Now after I do that, then what I want to do is I want to go ahead and put the rest of it, which is u, and that's 6x squared plus 3x. And I'm going to multiply that by the square root of 1 minus 6x squared plus 3x quantity squared. Now one thing I'd like you to do is I'd like you to go ahead and square this out and simplify this part right here. And for time's sake, I know you can do that. But again, make sure you do that going forward. And then this is the derivative of hyperbolic tangents. So we are flipping back to the other page. And it says to take the derivative of what's inside, which is 4x. And then the derivative of hyperbolic tangent turns out to be hyperbolic secant. And so we would go ahead and write that, and it's squared, hyperbolic secant squared, that is. And that's all we can do with that one right there. So integration. We have to make sure that we use substitution when we do the integration on these. So our first one that we have is we want to integrate hyperbolic secant squared of 9x plus 3. So in doing so, I'm going to have to do substitution because the derivative of what's inside is not 1. So I have that. I can then pull the 1/9 out front here. And so that's going to give me the integral of hyperbolic secant squared is going to be the hyperbolic tangent, and that would be of u, or in this case, 9x plus 3. And so I'll go ahead and put this with my work here. So this is the hyperbolic tangent of u, du. And so, yeah, the final answer then is going to be 1/9. And then that's going to change. Let me back up here. Too many things at once here. So in terms of u, that's what that would have been. So then this is 1/9 times tangent of 9x plus 3 plus c. For the second one, we need to rewrite this, and we need to look at formulas that we have here. So this is going to be dx, and so if I look at formulas, the square root of x squared plus 64. Well, that is the formula right up above here. It's the square root of u squared plus or minus a squared. So the plus or minus, it could be plus, it could be minus, and so when we use the rule, it could be the same thing in here. So it's either plus or minus, not both at the same time. So that's the rule we're going to use. So, but u squared and then a squared. And so when I work this out, I can go ahead and make this as x quantity squared plus 8 quantity squared. And using this rule then, I can use that and say, okay, well this is the natural log, and it's the natural log of u, which is x, plus the square root, and you'll notice from this formula up top, if I go back up here again, it's going to be the same thing. So that's going to be x squared plus 64. And then I can do that plus c as well. And then for our last one, the integral of dx 36 minus 25x squared. If I look at my formulas up top, I can go all the way back to the top, and I'll notice I have an a squared minus a u squared right here. So I'm going to write it in terms of that formula. So I'm going to have a 6 squared. I'm going to have a 5x quantity squared. So this is my u, this is my a. So u is going to be 5x. I have to do u substitution. Gets me to there. So I can then rewrite this in a small window here. I can then rewrite this then. This would be the dx would become du, and I'd have a 1/5 out in front of that. I'd have a 6 quantity squared minus an a u quantity squared. So then I can integrate it using the rule up top there again. And so when I do, that's going to be, again, this middle one right up here. 1 over 2a, and then the natural log of everything there. And I can just go ahead and make my substitution for this as we go. And so what I'm going to be looking at is I'm going to be looking at this. It'll be 1/5 times 1 over 2 times a, which is 6. And then that'll be the natural log of the absolute value of 6 plus u, which is 5x, and 6 minus u, which is 5x as well, plus c. And I can combine these on the front. That would give me 1 over 60. So that is how I want to integrate and derive with hyperbolic and inverse functions. Yeah,